Okay, so everything is already set up, so I can begin. So thanks everyone for coming. So I'm here to speak about Umeq, user mod emulation quest. So just to begin, who am I? Because I guess you don't know me. My name is Remi Durafort. You can find me under the nickname Ivoire on IRC or various medias. I'm working for ST Microelectronics and as an assignee for Linaro. As an assignee, I'm working on Lava mainly, and I've been working on open source software for 10 years now, mainly on VLC media player, that's my first thing as a I was VLC developer for a long time now, and on various projects, Pirut and V8 are the subject I was working on at ST before joining Linaro. And I will present Umeq, but I'm not the Umeq developer. He's one of my colleagues, but he cannot go to Linaro Connect, so I will present on his behalf. At ST, I'm part of the CEC team, which is the Compilation Expertise Center. So it's a team of compiler writers. So obviously we're writing compilers, nothing new, but we're also making engineering tools, because we have a lot of issues, obviously, and we like to create tools to solve these issues, and so we're creating engineering tools. And one part of the job of being compiler writers is to be able to validate compilers. So we are doing a lot of CIs for the team, and we are also doing CI for the whole system, the whole ST people, some other teams in ST. So to validate compilers, what do we need? We need to be able to compile and test ARM softwares, nothing new. So it's a classical configure, make test. So the requirements that we have to be able to validate the system is that we need some way to execute the ARM software, so even on a board or on an emulation. So if we want a board on an emulation, the requirements are the same for both cases. The first thing, we want something reliable, because if you want to do a CI system, you need something that gives you the right answer every time. If it gives you sometimes a wrong answer, it's not okay, because people will just say, your system is crappy, I will not use it anymore. It's the easiest answer, and that's the answer that people will always give you. So it has to be reliable. That's the first thing. If it can be parallel, it's really nice, because we can have many systems in parallel that are working, which is nice. And if it can be fast, that's a bonus. But that's only the third point. The first one has to be reliable. So why do I want something that can be parallel? I guess you all know that R64 boards are really expensive. Even if in this Connect they are presenting a new kind of board with 96 boards, for the moment R64 boards are still really expensive. While x86 processors or x86 servers are not that expensive compared to the power that you can get. That's where user mod emulation can be really interesting. If you don't know what user mod emulation is, it's a way to run, for instance, an R64 program on your x86, on this machine, which is an x86, like any other program. I'm in a shell, and I'm typing commands. They are running each R64 commands, but I don't see the difference. I'm just running commands like in a normal system. I don't have to boot a kernel, everything. It's really light way of emulation. And as you're running like a normal command, you can be multi-threaded. If you have 10 cores in your system, you can use 10 threads that are running parallel. You don't have the overhead of running a kernel, a virtual kernel, because you're running directly on your host kernel. And if you have available hardware, like you have a graphic card of OpenGL, you will be able to access it directly, like any other programs. So imagine if you have a really big server with user mod emulation, you can combine both and do massively parallel validation and test. So if I have a really big server, I can run make -G48 on my server. With user mod emulation, it will be like if I have 48 cores, R64 box for not that much. It will not cost that much. So, for qemu guys, I guess you know qemu. There is mainly two ways of using qemu. There is a system works in which you will boot a full kernel, a full system. It's really really good software. It works really well. It does works. Thanks for this work, qemu guys. And there is the user mode, which is the mode I'm interested in. And it's complicated because in user mode, if using signals and threads, something like that, sometimes it will work, sometimes it will crash, sometimes it hangs. It depends, and so it's not readable. And it's even written in the documentation. If you look at the qemu wiki, you will see that threading support is known to be broken. It's written down. I can do a small demo if you want. Really
it's okay, we know it's broken.
I guess you know it's broken. I just want to show you. So I'm using this command line. Proot is just a tool to confine an application into rootfs. So I have a Debian seed R64 rootfs. If you look at it, nothing special inside. Can do that to show you. You see it's R64 ARM. So I will confine my application in this rootfs thanks to proot. It's just a shroot-like tool based on ptrace, nothing special. So it will be, my application will be shrooted in this R64 rootfs, and every time an application in this process tree will want to do an exec, I will append qemu R64 static in front of this exec. So I will be able to execute commands in this rootfs, and everything will be run under qemu R64 static. So I'm just now bin bash that I'm running. The one that I'm running is an R64 one. So you see it's running quite well. I can do top, and you see proot here, which is the application. HTOP is maybe better to look at it. You see qemu R64 bin HTOP. So I'm not running HTOP directly, I'm running HTOP under qemu R64 static. So just to show you how broken is it. In many systems, when you do validation, you have timeouts to be sure that if something goes wrong, you will quit. And timeout is based on signals. And if you do this, which should quit after 1 second, it will just wait for the sleep to finish. It's just not working. And this is a good case because it's not crashing or hanging the application, it's still working. I have to wait for the sleep to finish, but at least it's finishing one day. Sometimes it's just crashing. So, sorry, but it's not reliable. So, that's where we have a new tool called Umeq for user mode emulation quest. So it's a quest for emulation. The name comes from a flip of concern. We come from qemu, which if you look at the documentation, it's written, it has to be a fast processor emulator using dynamic translation for achieve good emulation speed. So you see fast and good emulation speed. It's really a fast one. qemu is really fast. Umeq is absolutely the opposite. We want first to make it work, and then, if possible, make it fast. That's the philosophy of Umeq. So I will do a small debug because that's a bit more funny. So I'm doing the exact same command. So but instead of qemu, I'm using Umeq to run. So same thing is still working. HTOP, just to prove it, it's under Umeq. ARM64, HTOP here. Nothing special. Just to show you, if I'm doing this. So, oops, I typo. This is using signals. It's working. Sleep will be killed. Will receive the signal correctly after 1 second, which is what I wanted to do. Obviously, I can do a lot of things. I can do GCC, which is already working under qemu, so it's not a real example. But I can do also a lot of things that are just not working under under qemu 4 because they're using a lot of threads. So I can run VLC. It's just really slow, but it's working. I can have a graphical application. It's an R64 one that is running on my system. It's just really slow and showing on the wrong desktop. Up, this one. You see, it's working. I can access to the media. I hope you like UB40. Oops. And the sound is working. That's the funny thing. And funny thing, interaction with the desktop is working, as you see. You see it's increasing and decreasing. And dbus is working correctly. And you can, it's easily multi-threaded. If I'm showing you this, each of these most of this item is a separate thread. It's maybe too much but that's another discussion. But there is a lot of threads, and it's working. If you try to do the same under qemu, it will just crash because threads on qemu it's not a good thing. You can even try to play a video. Just my computer is really too slow for that. It's an old processor, so it's not working. But for instance, you can play. You can use Ocular if you want, the KD PDF reader. Again, it's really slow. It takes a lot of time to boot. But I can show you the presentation here. It's working. So I think we are the first people to ever see KDE application running on R64. I don't think anyone is taking time on a Juno to try KDE applications because it's too expensive. Just last one, just for fun. You can even play if you want to. Westness is working on window, obviously. This one. I have some issue with the sizing, sorry. It's working. The sizing is wrong, sorry. You can even play with this, I tried, it's working. And it's quitting correctly, so there's no crash at the end, nothing. So, it was a small demo, so if you want to try it, just come to me and I can show you some more demo. What are Umeq assumptions? So, for the guest, we are only able to run R64 programs. We have an ongoing ARMv7 support, but it's on hold for the moment because we are mainly interested by R64 programs. The host is only x86 64 bits. We don't care about other systems because we don't have any other system to run the test. The process isolation, so the fact that if I have a binary, a dynamically linked binary, I will need the libraries. So I need a rootfs in which to isolate this application. It's not done by Umeq. qemu is doing it partially. We decided to use another tool that we already developed, which is proot, to do that. So it's not done by Umeq directly, but another program. The release status of Umeq, it's still in a beta version, and we are making the right papers inside ST to have this the source code open sourced. We hoped to have it for today, but it took a little bit too long, so it will be in the following weeks. If you need to look at the sources or if you want to try, I can give you a binary directly from my computer directly if you want to look at it. The binary is not an issue, I can give it to you. So what's working? You can do validation with that because if you have a build system that uses CMake, it will not work under qemu, it will work under Umeq. GC is already working on both, so it's not an issue. MHE merge is a known problem with qemu. Sometimes it's working, sometimes it's not. It depends. It's not fixed. Threading, signals, graphics, they're all working. you see I can play music, so you can really try your softwares. I can do OpenGL, it's working. It's funny because when you play trying an OpenGL programs, you don't see the difference between a normal x86 one running on your machine or an emulated one, because OpenGL is all done by the graphics, by the graphic card, so you just don't see the difference. You can even do debugging of an application under Umeq. I will show you that just afterward. There is obviously still bugs and not implemented things. For instance, you can't run qemu system mode under Umeq. It's not working. I tried. We were missing some pieces to do that, but it should be possible. FPU status registers are not fully correct for the moment, but the status changed between the time I did the slide and now, because the Umeq developer did some fixes on that aspect. So I was speaking about debugging, so let's go back and try to, we are in this Debian seed R64 rootfs, and we're trying to debug an application. So I will use Strass, so just for information. If I'm looking at it, user bin Strass. Oops, sorry. It's an R64 one, so I will try to debug an R64 one program using an R64 program. So Strass, just been through to show you because it's just not working. It's not possible directly like this. The application cannot be p-traced. So if I'm using Umeq, I can try to do the same, and it's working. I have the trace that the application is doing. So I'm running Strass, an R64 one, on an R64 binary. Everything is under Umeq, and it's working. I can even do, oops, I have to set one variable environment to make it work. I can even try to debug Strass if you want. I can add a breakpoint in main and run. It's really slow, really slow under Umeq and GDB, but it's working. I can do info registers. I can backtrace, nothing really interesting to show. Can disassemble. You see it's an R64 binary. And I can step. Again, alpha registers, etc. And you can do a lot of things like that. So with that, you can test your R64 application. You can see it's crashing, and you can try to understand why. And the main reason why the Umeq developer made GDB working because he had some crashes, and he wasn't able to know if it was Umeq or the application that was crashing. Why it was really crashing? Most of the time it was Umeq fault, but sometimes we found bugs like this in applications on R64. And if you quit, it's quitting correctly without issues. It's okay?
So do you intercept actually syscalls or layer before, like libc?
If you're based on GDB is intercepting syscalls. GDB is based on ptrace.
I mean all the simulation at all.
proot, you mean?
No,
or Umeq?
Umeq.
I will. Umeq is it's just JIT code. It's disassembling code, R64 code, and transforming it into x86 code.
Yeah, but obviously you don't you do nothing with syscalls because
we are.
Yeah, no, but syscalls are executed by
the host, yes.
by the host
yes.
kernel.
Yeah, there is some syscalls that we have to change because the semantic is not the same on R64 and x86 64 bits. Sometimes the semantic is a bit different, so you have to on the fly change the syscalls so it can be executed by the host system, and it means something for the host system.
Yeah, so your emulation boundary is syscalls.
Yes, it depends. Some syscalls are just executed directly by the host without any modification. Some has to be changed. It depends on the syscall. Yes. But in fact, we are changing the syscalls only when needed, and it's when you JIT the code, you see the syscall passing, and you change the semantic of the syscall directly. So the question is, why is it working in Umeq and not in qemu? Because it should be working, honestly. So as I said, it's really a classical architecture, nothing special. It's just completely classical one. You have the R64 binary, you disassemble it, you have an IR, an intermediate representation of the code, and you JIT this IR representation to your target, which is x86 64 bits. So you get a bunch of instructions directly in a small memory, and you just call this memory, and every time if there is a return, you will return directly in the disassembler that will JIT the next byte piece of code you need, etc., etc. Exactly how qemu is working. I'm wrong, I guess. Normally.
Yeah,
So
for the 64-bit binary, is there any special requirement for that? Like you need debugging information there. If
no.
It's a string. It's also okay.
You just need you just need the binary directly. No debug information, nothing.
I mean the binary even stripped.
Yeah.
Also okay.
Yeah. You just need a blob of R64 instructions encoded in binary, obviously, like a normal program.
I suppose if the binary, some information is lost, so it's not easy to translate it to IR.
It's just instructions.
Yeah, it's just instructions. You're like a processor. You decode things. You know what it means, and you execute it.
Okay, great. Thanks.
Instead of emulating instructions, we are just translating the R64 instruction to x86 equivalent ones, with keeping the semantics. That's the only thing that we need to keep. It's the semantic of instructions that we have to keep.
Okay.
So, why does it work in Umeq? That's really simple, in fact. Is that you have to be sure that every function that you are using in your emulator is reentrant. And that's the main reason why qemu is not working in this case with threads. So you're JITting code, so you're in the disassembler, for instance. You get a signal, so you're interrupted by the kernel. You have to do something. You have a signal handler for that, right? And the signal handler will be in the R64. You have to execute it R64 code. So when you're disassembling, you have to disassemble this signal handler. So if you're not able to call the disassembler inside the disassembler itself, it will just crash. And that's one of the reasons why qemu is not working. That if you are disassembling, you cannot disassemble at the same time. Even it will crash, or it will take two locks at the same time.
But
or
you don't
try
want
to
to try and call the translator from inside the signal handler anyway, because that's going to fall.
Sorry?
You don't want to try and retranslate from inside the signal handler anyway.
If you are disassembling and there is a signal arriving, you have to be able to do that.
You've got to do something, but what you don't want to do is call the translator directly, because the translator is going to do a whole bunch of stuff which is just not safe in the signal handler.
Well, that's why we are actually doing that.
Yeah.
When there is signal handler, there is a signal arriving, we are able to be in a state where we can disassemble the R64 code and execute it directly, even if we are already disassembling things. And the reason for that, which is a bit strange way to do things, is that all the data is on stack, is on the thread stack. So each thread has its own cache. There is no global cache with all the data inside, so we don't need a lock for accessing this cache. And all IR, OGT code is on the stack directly, which has some inconvenience, to be honest, because you have to tweak a bit the parameter of the program at the beginning to be able to have a large stack, so you can have a cache in the stack. You have to change some parameters when you start the program, but it makes all code, all of this data thread local, and this way you can be reentrant. It's really easier to be reentrant. It's not mandatory to use data on stack to be reentrant, but it's way easier to be like this. And the second thing is that we never do any locking when we are in a signal handler. It's a special case. We don't do any caching of code blocks in signal handlers, because if we want to have a caching, we need to be able to store the cache somewhere. which is not possible when you're in signal handlers because you need to have a lock, and locking in signal handlers is just not possible because signal handler can appear in any whenever you're in the disassembler, for instance. If you're in disassembler, you have a lock, and in the middle, before you go to unlock, you have a signal. Then you have to lock again in the same thread, which is not possible. So we don't have any locks in signal handlers, never, ever, ever. So if you are reentrant, your data is on the stack, so it's easier to be reentrant, and you don't have any locking on the signal handlers, then it's working. And that's one of the reasons why qemu is not working, or is crashing or hanging. It depends. Even he tried to take two locks, or is trying to not use locks and crash because there is no locks. That's the main reason why Umeq is working.
qemu isn't working in this case because nobody has come along and said, I care enough about fixing this, I'm going to fix it. That's all. So the real question here is, why is it better to re-implement all of this rather than just saying, let's fix the bugs?
Yeah, that's one of the reasons I want to speak with you guys, is that it's a proof of concept that we know now how to be, we know the reasons, we know it's possible to do that. The performance are not that bad. They are really, it's really slower than qemu for this reason and some others. And we decided to work on Umeq more than to work on qemu, even if we already tried to fix that in qemu. Because it's easier for us to experiment. It's always easier to experiment with the smaller things. And we need your help to fix that, because we cannot do that by ourselves. We cannot do that because we don't have the knowledge of qemu that you have. So we need your help to be able to do that. If you want to do that in qemu, that's a question also. Do you want to fix user mode?
I would love to.
Do you have time to also? Because it's a long time.
That's the trouble. It's a prioritization thing. So some of this should get fixed by the TCG multi-threading system emulation mode, which will deal with a lot of the logging issues. And some of the rest is just, you've got to redesign a big chunk of the Linux user mode. People have sketched out plausible designs for this on the mailing list before. It's just that nobody's had a couple of months to actually fix it. We are looking a lot about on the mailing list, of qemu mailing list. We send mails about the user mode, and it often come back to, yes, it's possible, but no one has time to fix it and to prove that it's possible. This is a classic thing in open source.
Yeah, I understand that completely.
It's no good sending a mail to the mailing list that says this doesn't work. Is anybody going to fix it?
I know.
Because
that's the reason we wanted to try.
And if you care, well.
That's the reason we wanted to try that, to be sure that there is a design that is working, and it's easier to do that on a smaller project, because you can try different designs. It's not the first design that we had. The first one was based on having a p-tracing application to be sure that the ARCH64 binary and the emulator are not on the same memory space. At the beginning, it was two different processes. One was the ARCH64 completely untouched, and every time it is trying to execute code that is ARCH64 not already translated, the other application, thanks to ptrace, was able to change the code on the fly. It's working, but it's it's really too slow. So we decided to do another design. So it's easier to experiment. That's the reason why we try that. And also, if you want to have something like sounds to work, OpenGL to work, you need to do not touch syscalls as much as possible, because most are working without doing anything.
At least if you're 64 on 64.
Yes, exactly.
So
That's the reason.
You've got to do a lot of messing about with changing structure of that.
When you are dealing with IOCTLs from 32 bits to 64 bits, it's a completely different problem. But when you're in 64 to 64, most things are working without touching it.
So are you doing
being lazy is a good thing sometimes.
Are you doing your syscalls directly from the JITted code, or do you go out to helper functions?
No, we have we have helper functions.
Right.
Because we want to be able to support 32 bits too, so sometimes we have to change things.
So do you do anything special to deal with things like signal restarts, so if you get signals whilst you're in syscalls?
I'm not sure I'm not able to answer correctly to these questions. That's a good question. I will have to ask the Umeq developer about that one. But I know that we don't have that much issues with signals, mainly because we let the signals go directly to the application. We have only one basic signal handler, which is just let me digit the code for the signal handler and then run it correctly.
Yeah, it's usually the case when you get a signal whilst you're in a syscall
Yeah.
and where exactly you restart your
Yeah.
user
I will have to ask. I cannot answer that one. I'm sorry.
So, one more. Sorry.
Yeah,
So you mentioned that when you're in the signal handlers, your translations are ephemeral. You don't cache
Yeah.
any of your jittered code. But
You-
if they,
You throw it afterward.
right, but it can still call previously jittered code. So
Yeah.
library functions
Yeah.
that will go to
Yeah,
that
yeah.
and then come back.
Yeah, sure. Yeah, sure. Just the signal handler, it cannot be cached, at least not with this architecture, because you will need a lock, and you don't know your status.
Right.
Is the lock already taken or not? You cannot do that. So we think it's possible using lockless structures, but for the moment we don't need it, so we haven't tried it. But it should be possible with lockless structures.
You probably don't spend that much time in
Yeah,
signal handlers.
that's the reason we it's not really a performance issue. Normally you don't do that much things in signal handlers, so if you throw it away afterward, it's okay. It should be a small piece of code.
But to get around this logs problem, can't you just defer a little bit your signal?
So this is kind of what qemu does.
Yeah.
Is that you take the signal and you say, I was in the middle of doing something here,
Yeah.
set a flag, and I'll get back to it. And in principle, yes, that's the way I think that we ought to fix the problems with qemu is basically to fix this strategy up so that it works. But the difficulty is that you get. So one of the cases that qemu fails on here is where you're going along, you're just in your code, your guest code is trying to do something like a sleep 10 syscall. So you come out of your jittered code into the bit of qemu that's saying, let me do this big switch on whatever syscall we're trying to do, and then you take an incoming signal, and what you say is, whoops, I was in the middle of doing something, I'll have to get to that later, and then you go and you do your syscall for sleep 10, and that is then going to sleep for 10 seconds. But the semantics that you should have had is the signal arrived and the emulation syscall should return the integer immediately.
Yeah.
So you've got a race there basically that you have to deal with. You can deal with that, but the way you have to deal with it is that when in your signal handler you have to say, look at the program counter, host program counter where the signal occurred. If that is in this magic section, which is I am about to do a host syscall, but I haven't quite got to it yet, then you say, okay, we're going to have to mess around with the program counter, avoid actually taking the syscall, so that you can return the integer.
Yeah, so you basically need to implement interruptible critical section.
Pretty much.
Yeah.
You basically you have a critical section,
Yeah.
and you.
Yeah.
Because it's all similar to how do you lock between, for example, thread and interrupt. You just disable interrupts.
It's not rocket science. It's
Yeah,
just
it's
requires a bunch of work because this is not the way the code works at the moment, and you kind of would need to do a chunk of rewrite. But that would be the way that I would approach it.
Okay. And about debugging, it's a special. It's a bit complex to be able to debug an application that is emulated using GDB, an HKG15 GDB for this application, because proot, the application that is able to isolate your HKG15 application in this rootfs, is using ptrace for that. So it's ptracing every application in the tree, and the kernel forbids to have more than ptracer by application. So you cannot have GDB that is ptracing and proot which is ptracing. Both are not possible. So Umeq and proot are communicating to have a kind of ptrace emulation. So we are sending the right signal. Proot is in fact the only one that is ptracing the application, and is sending the right signal to GDB. So GDB thinks is ptracing the application, which in fact is wrong. It's not ptracing anything. So it's kind of a tricky game to make GDB thinks it's working, while in fact it's not doing the real work. But it's working. It needs some special patches in proot to be able to do that. but it's really useful, so it was done. So what's next? So it comes to your question, Peter. You can play with Umeq because you can already find bugs with it. We found ptrace bugs in the kernel. We found a gmalloc. Gmalloc is used by Firefox, Thunderbirds, and some BSDs. On Arch64, we found again a binutils bug that was found approximately at the same time by someone else. He was a bit faster than us to find this. It was when we tried to launch Blender that uses libpython that crashes in certain circumstances. It seems to be a binutils bug. Because it's reliable, that's the only reason why you can use it. That's the reason why we want to use qemu user mod and we can't use it, because it's not reliable enough. So complex programs like VLC, Firefox, Thunderbirds, you can try IMAP. I already sent a mail using Thunderbird over IMAP, it's working. Western Popular, everything. And you can do even debugging. And so, why not inside qemu? Just true answer. It's easier for us to experiment with something that we've written from scratch and with really small. The question now is, how do we collaborate so it can be done inside qemu for user mod, because it seems to be a good option to port this work on a really non-working project. So that's the biggest question. How is it possible to do that? Because it requires a lot of knowledge of qemu that we don't have.
Well, I think the difficulty here really is that the design you've picked is not one that works with qemu, because qemu's translation assumes you're not going to run it inside a signal ham. So, for example, we will happily call malloc from within our
we are not based on the libc at all.
Right, that's interesting. Yeah, so that's kind of, if you're trying to do this from scratch, then one of the interesting things is you can avoid using any libc, and that has its advantages. But it's very difficult to, if you've made some of those base assumptions, it's kind of difficult to take that design and put it into qemu. So the kind of the design you would want to fix these issues within qemu doesn't really look like this.
Mm-hmm.
So.
You want
I guess
to
the first interesting part would be to actually see the source code.
Yeah, and it will be in some weeks. I'm sorry, it's not available today, but we can send a mail on the qemu mail list if you want, when the source code is available, so you can look at it directly.
How much testing of your JIT and your code gen have you done?
Tested of the...
Yeah, how confident are you that you actually get all the instructions right and that kind of thing?
More and more confident, because we're using it a lot and it's really working. And we're...
That tests that you're getting the right answers for the instructions of GCC emits, which is not quite the same thing.
I know that. We're using Valgrind Arch64 validations to validate our jitter.
Oh.
Because Michael, my colleague that is working on Umeq, is working on Valgrind for Arch64 before. So he took the validation, the test from Valgrind to test Umeq directly. So he has a good confidence on the Arch64 decoding and translation. This is the easiest part, according to him.
It depends. It's like you can spend like 10,000 lines writing.
Yeah, I know. So yes, we think it's possible. It's feasible to do that in qemu also, but you need a good knowledge in qemu to be able to do that, because it's a lot of architecturing that to redo or to change. So if you have any more questions, you're welcome. And I guess you already know that I'm really fond of Monty Pythons and Jolly Grey, so thanks for the pictures. Do you have more questions?
So the JIT engine that you use, is it just your own JIT that you wrote, or are you using...
The jitter?
Yeah.
Yeah, it's a personal one. Yes. It's not based on TCG.
Yeah, as well, LLVM.
It's an unwritten one. Yeah. No more questions? Okay, so thanks everyone.